Hello, this is John from TC Math Academy, and in this particular video, we're going to be talking about solving systems of linear equations, and to be a little bit more precise about this, two variable linear systems. So here we have a linear equation, and here is a linear equation. Let me just write that word out here for you. Linear, right? So what's the root word here? It's a line, right? So these are equations of lines. In other words, you can actually take this equation and graph this, right? It would actually be a line. That's what we call this a linear equation. So we have a linear equation here and a linear equation here. And you see that we have two variables, x and y. And now, typically, when you first study systems of linear equations, you are going to be using the variables x and y, but they can be any variables a and b, w and z. So don't, get caught up with, what variables are being used in the system. But again, typically when you first learn this, you will be using the variable x and y. And we're trying to solve for x and y, right? So that's what it means to solve a linear system. So, what are the methods that we have at our disposal to solve systems of linear equations? Okay, well, that's a question I have for you. And I want you to think of this for a second. And again, if you have taken Algebra 1 or you're taking Algebra 1 or you have already studied this, you should know at least three methods. Okay, so what are three ways you can do this problem? So go ahead and put your answer into the comment section, but more importantly, go ahead and solve this system. You can use one of the methods that you know and see if you can actually solve this particular system. This is not overly complex. In other words, I'm going to be using, there's nice numbers involved, right? And you're not going to get any crazy fractions or decimals, anything like that. So the solution will be a nice, lovely solution. I'm going to show you that in just one second. Then I'm going to walk through all these methods. We're going to really take a good overview of solving systems of linear equations, and then I'm going to solve this using one particular method. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so if you know how to solve this linear system, well, then you should have come up with the following answer. Okay, so 0, 2. In other words, x is equal to 0 and y is equal to 2. So this right here is in fact an xy ordered pair, an xy point, xy coordinate. So typically, when you kind of write your solution to a linear system, you'll write it as an ordered pair, 0, 2. But if you wrote x is equal to 0 and y is equal to 2, that's perfectly fine as well. And if you got this right, that is fantastic. Let's go ahead and celebrate by giving you a nice little happy face, an A plus, a 100%, and multiple stars. You can tell your friends and family that yes, yes, you know exactly how to solve systems of linear equations, two variable linear systems. Now, I'm being kind of precise about that. I'm saying, okay, these are two variable linear systems because we're solving for the variables x and y. But as you progress in mathematics, we can throw in another variable like z, right? There are three variable linear systems. Then there's systems of non-linear equation systems. Then you can get into all different sorts of fancy type of systems that can get pretty complex. But the concepts are going to be kind of the same. And of course, you start learning, the basics with two variable systems of linear equations. Okay, so that's kind of what the whole point of this video is, just kind of give you the big picture. So let's go ahead and get into the question that I had, at the very top here was name three methods that you can use to solve this system. Okay, this system of linear equations. So let's go ahead and review that real quick. Now, there are some more systems. So if you didn't, if you wrote other methods and not these methods, that's perfectly fine. I'll name a few other methods here in a second. But for those of you that are just first starting out in algebra, when you first start learning to solve systems or what a system is, you start off by understanding the graphing method, because this is one way you should know. So what does the graphing method entail? Well, it's pretty straightforward. we're break out a piece of graph paper. We're going to graph this linear equation. So of course you hopefully know how to graph online. So you got some options here. You can just rewrite this into slope-intercept form or find x, y intercepts. Doesn't make a difference. You would graph this line right here. Then you would graph this line right here. And what are you looking for? You're looking for the point of where those two lines intersect. Okay, so that is visually speaking, or really the main concept of systems. Here we have one line. Let's call this like line 1. This is line 2. So where these two lines cross, that specific x, y point, is in fact the solution to the system. That's what you're looking for. So when you're solving systems, you're really looking for the point of intersection between lines or planes or whatever you might have, right? So, and systems that involve functions that are not linear, okay? Things like a circle, you can have like a circle and maybe like a parabola, and that's kind of like, a quadratic function and a circle conic section. You're still looking for the points of intersection like so, okay? So just a big picture concept. So the first method is the graphing method. Okay, you should be familiar with that. But this is really not the most practical method, okay, because you got to graph and you got to look, and you got to be absolutely precise. So really what you want to do is focus on your algebraic methods of solving a system of linear equations, and here are the two most famous. I remember learning about this way back in the early 80s when I was in high school. I'm pretty sure I wasn't really paying that much attention because I wasn't the best student, but I do remember these methods. And the first is the substitution method, okay? And the next is the elimination or linear combination method. Okay, so these are our two methods, and these are our primary tools to solve systems of equations, right? So it's important that you understand the graphing method and you can actually do this, but really we're going to be solving 99.9% of two variable systems using a substitution and elimination and or linear combination method. Okay, so now I did say that, of course, these are three methods. These are three methods that I hope you answered with. But if you came up with some other methods, that shows me that you are really a algebra superstar. So let's just talk about a couple other methods that you could use to solve this system. Now, both of these methods, you would learn like at the Algebra 2 level. Let me kind of make this clear. All this right here is stuff that you will learn like first year algebra, Algebra 1. But when you get into a little bit more advanced math like Algebra 2, college algebra, you start getting into things called matrices, right? You can start using a matrix to actually solve systems, and that's really, really cool. So you can actually use matrices, and there's two techniques that come to mind. You can use an inverse matrix, okay, and that's a whole nother kind of topic. If you're at that level of math, I teach this in my Algebra 2 and pre-calculus courses. You just go there and you'll see these methods. So this is one method you can use, an inverse matrix to solve this system. And there's another cool technique called Cramer's rule. Okay, you're like, what's that? Cramer's rule? Well, it's another awesome way, and it involves matrices. Actually, it involves something called determinants, okay, which are part of matrices or the topic of matrices. So these are other methods that you could use to solve this system. And again, this is a little bit more at like the Algebra 2, pre-calculus, college algebra level, okay? But, if you listed these as methods, then that's perfectly fine as well. Now, these are really kind of the main methods that you use. Of course, are there other techniques? Yeah, probably. There's other ways you could approach this, probably. But these are the main techniques that you learn like in like high school, basic college level mathematics. Okay, so now let's go ahead and get into solving this system. So here, okay, I'm going to suggest to you, as I did here a second ago, that 99% of the time you're going to, even when you know the Cramer's rule and inverse matrices, you're not going to select these as a kind of a primary tool to solve this system. You're really going to be focusing it on the substitution and or elimination linear combination method. Okay, now it's really up to you here, okay, which one you use. Now, there's times with experience you'll see, ooh, this is a better candidate for substitution. This is a better candidate for elimination. There's definitely times where one method is better than the other, but don't do what a lot of students do, and they kind of fall in love with one method. They're like, oh, I just love the substitution method, and then they just use a substitution method on all prompts. That's not a good thing to do. Okay, yes, you're getting really good at the substitution method, but you need to understand the elimination method as well. Okay, and oftentimes this is the easier method to use, and your teacher will want to see that you know both methods. So kind of mix it up, and but let's go ahead and take a look at this problem. And for me, I'm going to say, you know what? I'm going to approach this using the elimination linear combination method. Now, I cannot possibly teach you everything about every one of these methods. That's a lot of instruction. So again, if you need help with this, just check out those particular courses. Also have additional videos on my YouTube channel as well. But what's the essence of the elimination linear combination method? Well, the elimination part means we have two variables here, right? We have x and y. We're like, how do we solve for this? Well, if we had an equation with one variable, let's say we have 5x plus 2y is equal to 4. Well, if we had an equation with just 5x plus 2 is equal to 4, well, this only has one variable, right? And here's a number. So we could solve this even if we had the equation 5, whoops, let me go write this here a little better. 5 plus 2y is equal to 4. Just notice I'm just eliminating one of these variables, right? So when we have linear equations with one variable, just solving basic algebraic equations, you should already know how to solve these, right? But we can't solve these right now because they have two variables. So we want to eliminate one of the variables, okay? That's what this means. And then the linear combination part of this basically means that when you have a system like this, you have one equation and another equation, basically what you can do in a system is you can combine two equations to make a third equation. Okay, so in other words, here I could kind of squish these together like a peanut butter and jelly sandwich. I'm like, okay, 5x and 2x, I got 7x plus 2y and 5y, that's 7y. That's equal to 14. So this equation here, okay, is equivalent to these two. It's equivalent in terms of being a part of this system. Okay, in other words, this is a technique that you can use. You're allowed to combine two equations to form a new equation in an effort to solve a system. Okay, so I really don't want to try to go down, try to overly explain that concept, but hopefully it's something that you need. Now, if you're already kind of confused, then you really want to slow things down and get some full instruction, okay, on this. But this is basically what the elimination and linear combination mean. But here's really what we want to do. We want to eliminate one variable. But how can we do that? Well, we can combine combine these equations, okay? And we want to be able to eliminate one of the variables. Now, another rule of systems that you can do is you could take a system and multiply the entire thing by any number you want. So like this system here, I'm like, you know what, I want to just multiply it by 10. No problem. Okay, you can take this 10 and multiply it by this. So well, let's use an easier number. Let's say like 5, right? So this could be 25x. I'll just use the distributive property. Plus 5 times 2 is 10y is equal to 5 times 4 is 20. So again, these are rules that you can use to solve systems. So you could do this. You can multiply an equation of a system by any number, and you can also combine two equations to make a third equation. Okay, so lots of leeway in terms of the things you can do with the system, but we want to not just do any random stuff. The objective is to eliminate one variable. Now here I have 5x and 2y and 2x, and I have 5x and 2y, and here I have 2x and 5y. So how do I eliminate a variable? Well, if we're going to add down, what we want to construct is opposites, right? So for example, here, if I have 5x, well, it would be pretty cool if I had a 5x in this first equation and a negative 5x in this second equation because when I combine down, I'm going to get a 0x. Okay, in other words, I'm going to eliminate the x variable. Okay, now I could have the same situation with y, right? I'm like, oh, I got a 2y and a 5y. What if this was a negative 2y? That would be so cool because when I combine this, the y's go away. So that's what you want to be thinking about when you're using the elimination combination method. You want to use the rules of systems to construct two opposite values, one positive, one negative, one variable. Okay, pick either the x or the y, and you're going to have to kind of clean up or manipulate one or both of the equations to create an opposite situation, like a 5x and a negative 5x, or a 2y and a negative 2y. Okay, then we could combine this, use linear combination to eliminate one variable. Okay, so let's go ahead and see how I'm going to do this. So I'm like, okay, I'm going to work on creating two opposites here for the x's. Okay, now I just can't have 5x and negative 5x. So what do I need to do? Well, I'm going to come up with the same number, but just the opposite signs. So I'm going to multiply the first by a negative 2, and by doing that, this right here is going to give me a negative 10x, and then I'll multiply a 5 by the second equation. This and that 5 times this 2x will give me a positive 10x, and this will be my opposites, right? Then I can get rid of the x variable. So you can pick either the y variable to get rid of or the x variable to get rid of, but what you need to do is manipulate one or both of the equations to create opposites. Okay, so here's what I'm going to do. I'm going to multiply this first linear equation by negative 2, and then I'm going to multiply this second linear equation by 5. So let's go ahead and do that right now. All right, so when I do this, here, let me just show you the work. So negative 2 times 5x, negative 10x, negative 2 times this 2y, negative 4y, negative 2 times this 4 is negative 8, and 5 times 2x is a positive 10x, 5 times 5y, positive 25y, 5 times 10, of course, is 50. Okay, so now I have an equivalent system. So just make sure you understand mathematically, this is the same or equal to this system mathematically. So different numbers, but basically the same system, just written in a different way. But the advantage here is like, oh, look at this. This is so awesome. Now when I combine these x's will go away. And it will just leave me with one equation with the y variable. Okay, so this is the name of the game. So let's go and do that right now. We're going to apply our linear combination. We're going to basically kind of squish these two equations together. So negative 10x plus a positive 10x is 0 10x. That goes away. Negative 4y plus a positive 25y is 21y. Negative 8 plus a 50 is 42. And then here I can solve for y by dividing both sides of the equation by 21, and I get y is equal to 2. Okay, so now we have our y coordinates. So remember, these systems, or these two linear equations, intercept at some xy point if indeed they have a solution. Now, sometimes systems do not have a solution, right? When would that be? Well, when the lines are parallel to one another. So this is a big, big topic, and if you're already like, oh, Mr. YouTube Math Man, you got me so lost, you need to slow down. Listen, use this as feedback. Make yourself a little shopping list, a math shopping list. I need to learn this. I need to learn that. I need to learn this. Slow things down. Get back to the basics, right? So if this system does have a solution, it's where the two lines cross. And here we have y is equal to 2. So we know the y coordinate of our xy ordered pair. Okay, so that's pretty cool. So now we need to get the x coordinate. So how do we do that? This is actually pretty easy. So we know that y is equal to 2. And here's our original system. So just pick the first equation or second equation and substitute in 2 for y, right? We're going to replace this y with the 2 and then solve for x. So I'm going to go ahead and use the first equation. You could use the second equation, doesn't make a difference. So here's our first equation, 5x plus 2y is equal to 4. So I know now that y is equal to 2, so I'll replace with 2 for that y. So this leaves me with the equation 5x plus 2 times 2, or 5x plus 4 is equal to 4. Now I'm going to subtract 4 from both sides of the equation. That gives me 5x is equal to 0. Divide both sides of the equation by 5, you get x is equal to 0. Okay, so that leaves me with x is equal to 0 and y is equal to 2, meaning that these two lines right here, okay, in this system, these two linear equations intersect at the point 0, 2. Now, if I was using that graphing method, I would see that. But the problem is here at 0, x is 0, y is 2, when you're graphing these lines, it may not be so clear, especially if you don't have graph paper, that the value here is 2. Okay, you might kind of estimate it as 1.8. That's why you really want to, it's good to know the graphing method, but it's not a practical method. Okay, algebraically, you can get the precise answer, but again, you could have done this problem using the substitution method or Kramer's rule or inverse matrices. There's a lot of different tools you can use, and you do need to use or know all of these and practice all these techniques. Now, if you use the substitution method, that's excellent as well. So there's no, kind of judgment. Like, wow, you should have used the elimination. You could use the substitution method. The only thing with the substitution method on this particular problem is you got to be comfortable working with fractions. Okay, so if you really don't like fractions, first of all, you just must know fractions to be successful in algebra, but you're going to get a lot of fractions if you take the substitution route. Anyways, lots of different options. The bottom line is you need to be able to solve systems of linear equations to be successful in algebra. All right, so hopefully this video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.